Greetings, welcome to the first best practices video for 5th grade. In these videos, we will share what one could expect to see and hear as they visit mathematics classrooms. My number senses seem to be tingling here. Something seems wrong with these prices. What do you think? Well, in this 5th grade unit, students will explore how place value affects the value of digits in both whole numbers and decimals. This 5th grade unit of study will encompass the following key learning goals. These goals can also be found on the STEMscopes parent letter. I can make sense of place value within multi-digit numbers, including with decimals. I can reason that a digit in one place represents 10 times what it represents in the place to its right, and therefore 1/10 of what it represents in the place to its left, and this is including with decimals. I can recognize patterns in the number of zeros at the end of products when multiplying by multiples of 10 and powers of 10. And I can reason about where to place the decimal point when a decimal is multiplied or divided by a power of 10. What should we see happening in the classroom to help students achieve these goals? Here we see snippets from some of the STEMscopes explorers. Notice that in all examples, students are modeling with either base 10 blocks, place value discs, or coins. They're then recording this work using pictures and expressions. This is all part of the concrete, representational, and abstract approach, otherwise known as the CRA approach. With CRA, we want to show the connections between each model, so teachers may select different students' models and strategies to discuss comparisons. You'll notice a mini copy of the mathematical thinking and reasoning poster in the corner. This is to remind us that the MTRs are how students demonstrate their understanding of mathematics. These explorations by students in the classroom could demonstrate MTRs 1, 2, 5, and 7. The types of questions we ask of students will help dictate the types of conversations our students are participating in. Here are a few examples of math chat questions from STEMscopes. Notice that these questions are typically open-ended and elicit thinking and explanations from our students. The conversations elicited by these questions could demonstrate MTRs 1, 4, and 6. As students engage in explorations and discuss their learning, we should hear mathematical vocabulary being used by both the teacher and students. Here's a list of some of the possible vocabulary terms that we would hear in this unit. This list can be found on the STEMscopes parent letter as well. Throughout the unit of study, we should see multiple opportunities for students to demonstrate their knowledge and understanding. This could include students' journals and their exit tickets during the explorers, or show what you know tasks as a follow-up. Students may also use the fluency builders with games to practice and elaborate on their content knowledge. These activities also provide the teacher with informal assessment to gauge the student's understanding throughout the unit. These activities could all demonstrate MTRs 1, 2, 3, 4, 5, and 7. As we visit classrooms, we may want to ask students questions to better gauge their understanding of the current content. Here we see a couple of different questions that we could ask to gauge their understanding with place value. These questions come directly from the benchmark pages on mathsmarts.com, which can be found by clicking on any of the benchmark links in the instructional guides. The students' explanations of these questions could demonstrate MTRs 4, 5, and 6. We want students to continue their learning at home, and most likely we would want them to bring home an engaging task or activity. These activities are both taken from the STEMscopes parent letter. Here, students could play a game of Guess My Number, where one person thinks of a number with a decimal, and the players take turns asking questions in order to try and guess the number. Another task could be Would You Rather, where you ask children real-world questions involving decimal values and ask them, which would you rather have? Even though this is not in the classroom, these are still great demonstrations of MTRs 3 and 7. Why is place value so important, especially when dealing with decimals? Well, hopefully through the real-world connections in this unit and the models that students used, they will have built an appreciation and understanding for the importance of place value. After all, who could have ever known how important decimal place values, even to the millionths place, could have been for something such as cryptocurrency? And who knows what our students will use place value for in the future? Well, I know one thing that's in your future is another edition of our 5th grade best practices video.